Here's Anatolii again. So in this video we'll create a simple sine wave based on lookup table in VHDL. It is not the best way to create a sine wave in FPGA, but it works, and at the beginning it will be useful enough, especially for functions like PWM and so on. So let's get started. Okay, as you can see, I already have opened and created template for the VHDL file. So okay, we have an entity called sine LUT, which stands for lookup table, and here I still didn't put the ports, so let's do it together now. So one would be clock, yeah, so it will be input port, and let's do it standard logic. Another one, let's do the reset, so it's very classic setup to have clock and reset, and this one also would be standard logic. And then we want to have our sine wave or lookup table, so let's call it sine, and obviously it's gonna be output, and yeah, it cannot be standard logic, rather it will be standard logic vector, so an array, and let's make it 16 bits. Starting from 15 down to 0, and don't forget that the last one we don't need to put a semicolon here, because semicolon is already at the end after this bracket. So here how we do it. Okay, another point here, we need to create a lookup table. So to create a lookup table we need to define a type which would be lookup table type, and we need to specify that it's gonna be an array, and let's use 500 values, so we'll make an array of 500 values. So yeah, this is the type, and okay, we also need to set that the array is a set of integers. And now we need to create a constant of this lookup table type. So we call it constant, and let's call it LUT lookup table. The type we already created, so it's LUT type. And now we need to put the values. So to put the values first, we have to generate them, right? So we'll use Python for this. Actually, it's a very good tool for it. So I already created a file, lookup table, and let's generate it together. For it we'll need to import numpy as np. From numpy we'll also need to use sine and pi, and let's also use matplotlib just to plot it and see if we're right and so on. Okay, so I create the array between 0 and 1, 500 values, and our signal would be sine, sine of in this array. So let's plot it and see how it goes. Okay, yeah, it's good. So the first thing we can see, yeah, the sine wave definitely ranges between -1 and 1. So the first thing is we don't need negative points. We need all of them positive. Another thing is that sine wave is symmetric, so we don't really need this part. We can only use the half wave, and then in VHDL we can invert the other half. So like this we can increase amount of points in our lookup table. So let's use it this way. So instead of 2pi here I will minimize it to pi, and then what I also want to do, okay, first of all I will multiply it by, let's make it between 0 and 15,000. So I'll multiply it by 15,000. And another point is I also want to shift it up, so it's gonna be from 15,000 over 2 to 15,000, and then we'll make it negative, well, false negative, so it will be from between 7,500 to 0. So we multiply it by 7.5k, oops, and we also add the same value. Okay, and this is our lookup table. So now we need to print it and copy. So let's use for loop, and I would like to use enumerate function for I index and value in enumerate lookup table. Okay, let's check first. Let's put here 50 for now, and let's check if this first one should be index and the second one should be value. I always forget about this, so I think it's better to check it. Yeah, so I is index, and we see all of the indexes between 0 and 50, not including 50, and values, all the values. So what I would do, I will say if index something like this. So if we can divide index by 20 without anything left, let's see what happens. Print I. Okay, we see that every 20th disappears. So if this condition is true, so we will print our value, and we also make the end line not the next string, not the next line, but column. Okay, and after this, when we have the other condition, we also print the value, we also put the column, but then, yeah, let's just print empty. So, okay, now it's not really clear what is going on here. Another point I want to do, I want to make this integer, and this one as well. Okay, so yeah, so 0, 1, 2, 3, and then it goes to 20, and then it moves on to the next string. So now we bring it back to 500 points, and let's just copy this part and put it into our lookup table. And also let's make it maybe like this so it looks nicer. We can also tab it here, and that's gonna be enough. Okay, so now let's start coding. So we need to create a process with a sensitivity list of clock and reset and processes, begin and process, all the standard things. Here what I want to write, that if our reset is 0, so if our FPGA just started or it was resetted, then let's create some counter. Variable counter is integer, range between 0 and 500. So if this one is 0, then we'll also reset the counter. And let's create one more variable. Okay, lookup table signal, which is okay, this one is integer, right? So let's make it unsigned, 16 bits. And we'll also reset it here. Lookup table signal, reset. Okay, so if reset is 0, we reset everything, right? Else if we have rising edge of our clock, then we count. So if counter more than 498, which means that if it goes to 499, because our lookup table is between 0 and 499, then we reset it. Else we add it, we increase it. Okay, and now I think we can assign this variable lookup table, assign it to the okay, to unsigned. We need to convert it. We need to convert this value. So lookup table, and here we put counter, and we should specify that it is 16 bits. And after that, okay, I think maybe we don't use it as a variable, rather we use it as a signal. So we can use it outside of the process loop. So yeah, and then we'll have to change it here, the assignment operator, to this one for the signals. Okay, so lookup table signal, we assigned our lookup table values with the counter. And here outside of the process, what we also do, we assign our output port and convert it to standard logic vector. Okay, so I think it should be enough. Let's copy it to the Vivado and try to simulate. So I copy, save it, and here in the sources in the project manager, I set it as a top value. And let's try to simulate it. Oops. Okay, so we have some problem. Let's see where we have the problem. Okay, so the first problem is that it's not integers, it's integer. And we see it's highlighted red automatically. I hope that's it for the mistakes and errors. Let's see. Okay, so yeah, it seems that it's fine. So if I simulate it, nothing happens. We have a bunch of orange lines, which tells us that there is some problem. It's unknown value. Okay, so first thing we need to do the reset, and we force it as a constant, and we need to set the clock. Later in this video, we'll make a test bench, so all of these values they automatically set. Okay, we see that reset is 0 now, clock is switching, yeah, and okay, at this point we can force the reset to 1. Whoa, force constant. And let's see what's going on. Okay, we see some changes here in the lookup table and in Sine. Okay, we can take either of them and make it as analog. So you see, this is what I was talking about. So we have repetitive half of the sine wave, and now we need to flip it. So we need to flip it at, yeah, this point. So at one point it goes up, at the other one it goes down. It's not really difficult to do. Okay, so let's shut it down. Let's close it. And here we go back here. What we need to do? We need to create another signal, and let's call it state. And this one will be just a standard logic. It will be a Boolean, which will change between 0 and 1. Okay, first thing first, we need to reset it as well initially. Yeah, it can be any value. It can be 0, it can be 1. And then every time we reset our counter, we flip it. And to flip it, we just write state, assign, not state. So it will just flip. It was 0, it will become 1. It was 1, it will become 0. Okay, what we can do with this, we can use another if-else clause. So we can say if it's 0, we just pass the sine wave as it is. If it's 1, we pass another value. We can do it as if, but there is another way to do it in VHDL, and this way I like it and prefer using it a lot. So we use when. So our sine wave is lookup table signal when state equals 0. Else we assign standard logic vector. We assign another value which will be 15,000 minus lookup table. Okay, so let's copy it, put it here. Let's see if we have some errors. And we do have the same old error again. Okay, let's also change it here. Yeah. Okay, let's save it and see. Okay, now it seems everything's fine. Let's delete this. Okay, let's hope that now we also can simulate it without any errors. Okay, so yeah, looks it's fine. Sine, here we have another problem anyways, so let's reset it. 0, clock 1 and 0, and at this point we start operating. Okay, so again something is going on, and okay, we see that the state is changing every time we change the counter. Let's see what we can expect in the lookup table as it is. So we didn't change anything here. What we changed was the output, and let's see if it actually did change, which did. So yeah, I think it's pretty nice. What about you? Yeah, let's change its color just for fun. Orange would be nice. Yeah. Okay, so let's cover one more thing in this video. Let's create the test bench, so we don't need to put this reset and clock all the time. And to make a test bench, let's copy this, create new one, and yes, to make a test bench, first of all we need to create a new file, and then we don't need any ports. So, and usually in FPGA they write TB, which stands for test bench. It's not mandatory, but it's kind of rule of thumb. So you also put it here, and I think that's it. Another point is, let's delete all of this, we don't really need it. Another point is we need to put a component there, a component which is some other VHDL block, some other entity, let's call it this way. So we put it here the way it usually is in any other file, so we just put it as entity, but instead of entity we set the keyword component. So now it means that this entity consists of this component inside. If we add more components there, it will be like hierarchical, so it will consist all of them. Okay, so let's delete also all of this. So now we need a couple of signals, a couple of variables, and let's define them as signal clock, and let's call it clock test bench, reset also test bench, and it will be standard logic. And the other signal, sine test bench, for example. Yeah, can we do it? Yeah. And this one would be the same standard logic vector. Okay, so the first thing we want to do, we want to create an instance of our component. Let's call it sine0, and the component would be sine lookup table. And now we use the keyword port map. And here we're doing the mapping of this component. So the syntax is simple. We put the port name, this one, and then we do this operation to assign some variable. So clock would be here clock lookup test bench. Reset will be reset test bench. And sine will be sine test bench. Okay, so yeah, this should work. And then we have two more things to do. First, we need to make the reset, and we make it 0 initially, and then we put it 1 after 100 nanosecond. And for clock, we can do the clock in the process. In test benches, we don't need any sensitivity list for processes. So here what we can write clock test bench equals 0, and then wait for 100 nanoseconds. And okay, we can flip it, or we can just make it 1. And then again we wait. Okay, so let's copy it in Vivado and see if it gives us some problems. Yeah, first of all I need to create this file. So create file sine lut tb. Okay, finish. Okay, yes. We open it, we just copy paste it, save. Okay, so the first thing we see is that now it has this plus icon here, which means that inside it has some other component, which is sine 0, as we called it here at this point. So now to simulate it, we need to create this source as the main, as the top. Otherwise it will simulate our sine LUT again. So let's set it as top. And let's try. Okay, so yeah, we also see this hierarchical structure here. And we see that we have clock, reset, and actual output value. And we already see that it did simulate it. And the reset was 0 during 100 nanoseconds, first 100 nanoseconds, and then it was set to 1. And clock is changing, toggling every 100 nanoseconds. So this is how it works. Now let's look at our sine wave. Yeah, we need more values probably to see it. Yeah, so it looks very nice to me. Okay, so let's shut it down. And maybe we can even put it on our block design. So let's open our block design and yeah, let's put this file here. So right click, add module, and it was sine lookup table. And we see here that our sine lookup table box has clock input, reset input, and sine output. So if we select it and press F7, yeah, we go inside the file. Okay, so that's it for this video, and see you the next time. And don't forget to subscribe.